technology now exists to use brain waves for remote control applications. Here at the University of California, Irvine, we've been working on using EEG brain signals to remotely control the movement of a robot.
What's new about our work is that the person controlling the robot no longer need remain seated or stay still. Instead, the person can freely walk around.
EEG is a way to record the natural electrical activity of the brain. The brain generates weak electrical signals that can be measured and sent to a computer. We measure electrical signals using a custom-built EEG system made by Advanced Neuro Technology. This system fits inside of a backpack and can be connected to a notebook computer so that we can process EEG signals while the user walks around. A brain-computer interface uses the results of this signal processing for communication and control.
Signal processing by the notebook computer inside the EEG backpack is used to control robot movement. The robot that we use in this research is a P3AT robot made by MobileRobots. This robot has an onboard computer that is wirelessly connected to the EEG signal processing computer.
The end result of this processing is the generation of movement commands like turn left, turn right, go forward, or stop. These commands are then sent via wireless network to the robot, which carries out the commands.
Different mental activities generate different brainwaves. We use EEG to measure brainwaves and send them to a computer for processing. Brain-computer interface software on the computer works by analyzing signal strength at different frequencies at different locations on the scalp. The results of this analysis are used to determine which commands to send to the robot.
The brain-computer interface uses the direction in which the user is attending to indicate to the robot which way it should turn. Now, normally when we're paying attention to something, we will have some outward signs of that attention. We will face our body or our head or our eyes toward what we're paying attention to. But to control the robot, we use something called covert attention. This is where we shift our attention without shifting our body or our head or our eyes. So that would be similar to maybe facing one person, but then really paying attention and listening to someone else off to the side.
While the current technology involves the use of the somewhat bulky backpack system seen here, people elsewhere are hard at work miniaturizing all components used in the system. This will allow for the transfer of this type of system out of the laboratory and into everyday use.
Work like this will likely find application outside the lab, particularly for control of autonomous vehicles and robots. For example, cars are being developed that will drive themselves. We will nevertheless want to be able to sit in these cars and control them should the need arise. EEG can be used to provide such high-level control. Likewise, industrial robots require intervention, and EEG can be used to provide high-level control in such cases.